All right, welcome here. We are going to do the Unit 4 sample work for Algebra 1B Part 1. Unit 4 sample work is about 22 words, shall I say? Yeah, 23 words. So it's moderately long. I have tried to eliminate any duplicates, words that we've already defined in previous units and stuff. All right, so let's get started. Number 1, a statement. A mathematical expression, or a math expression, that is true or false. Okay, example, 2 times 5 equals 11. This one happens to be false, but it is a mathematical statement. Okay. Next word, inequality. A math statement including a less than, greater than, or a not equal to. Example, 5 is greater than 4. Inequality. Solution set. The set of numbers making a statement true. For example, in 5x plus 2 equals 7, or actually, let's do equals 17, the solution set is 3. And we put solution sets in braces. Solution set. Set notation. Using curly braces to outline a collection that makes an equation true. Set notation. So in this particular case, if I have x plus 2 times x minus 4 equals 0, the solution set is -2 and +4. Solution set. Set notation, okay. Set notation is what we just did. Empty set. A set with nothing in it. For example, 5x plus 1 equals 5x. Has no solution, so the solution set is an empty set. Okay, we can do it that way, or we can do the Greek letter phi, a little circle with a slash through it. Addition property. You can add the same thing to both sides of an equation or inequality. And you may note that I'm combining two words, addition property of equality, addition property of inequality. So in this equation, x plus 5 equals, actually I better make it minus, x minus 5 equals 9. We add 5 to both sides, giving x equals 14. We've just used the addition property by adding 5 to both sides. Subtraction property. You can subtract the same thing to both sides. Of an equation or inequality. Okay, so x plus 5 equals 9. Subtract 5 from both sides, and you're using the subtraction property. Multiplication property. Okay, I'm going to combine again, like before, both equations and inequalities here, but there is a special exception for inequalities that we want to highlight. Okay, you can multiply both sides by the same thing. Okay. However, if you multiply by a negative, flip the equals, not equals, less than, greater than. If multiplying by a negative. Okay, and you may say, well, what happens when you flip an equal sign? You get an equal sign. What happens when you flip a not equals? You get a not equals. But when you flip a less than, it becomes a greater than. And so on and so forth. So let me give you an example from the inequality world. We're going to multiply, so let's say we got x divided by negative 2 is greater than 4. We're going to multiply both sides by negative 2. Multiply both sides by negative 2, yielding x and negative 8, but the greater than flips over to become a less than. So x is less than negative 8. Multiplication property. Division property. You can divide both sides by the same thing. Flip the equals, not equals, less than, or greater than if dividing by a negative. Example, negative 3x is less than 6 or 9. Yeah, like 9. Divide both sides by -3 and flip the inequality so that x is greater than -3. Division property. Inverse operations. Operations that undo. Or opposites. Opposites come in plus and minus, and times and divide. Examples: to divide 3 times 3 is 2, because divide and times are opposites, inverses. 2 plus 3 minus 3 is 2, because plus 3 and minus 3 are opposites and cancel each other out. Inverse opposites. Identity. Your identity is who you are, and it does not change. So the identity is something that does not change things. Example: 5 times 1 is 5. So 1 is the multiplication or multiplicative identity. 5 plus 0 is 5. So 0 is the additive identity. Multiplicative identity. Additive identity. Identity. It's a rather abstract concept. Okay, next. We're up to number 12, real number set. Okay, the real numbers are all numbers except complex numbers, which we haven't learned about. So all the numbers you can think of are real numbers. And when a solution set is everything, we use the symbol capital R with a kind of fancy twist. That's in relation to this symbol, which is integers. And there are other symbols for other number sets as well, but capital R is the one we need to know for everything. That's when a solution set for an equation is everything. Okay. Linear equations. Of the form ax plus b equals 0. Okay, that means it has the highest power of 1 on x. So no squareds, no cubes, they're linear. Example, 4x plus 3 equals 9. Linear equations. Solution. Trying to think if we've done solution before. Don't think we have. The value or values that make a statement true. The solution to 5x plus 3 equals 13 is x equals 2, or the solution is set 2. Solution. Okay. And I'm going to skip the next two. I'm going to remove them because they are multiplication and division properties of inequalities, which I've already covered. So that'll reduce our set by 2 here. Intersection of sets. The set containing only elements in both sets. Okay, so for example, the set of prime numbers and the set of numbers less than 10 is, and this is the intersection, so the symbol is this, looks like a upside down U, is the set prime, 2, 3, 5, 7. Those are all the numbers that are both prime and less than 10. Okay. Intersection of sets. Okay, and we also include, by the way, the symbol and with that. When you see the word and, an intersection of sets is implied. Okay, union of sets. You want to include the word or. The set containing all of both sets. Okay, so 1, 3, 5, 7, the prime numbers less than 10, union the odd numbers 1, 3, 5, 7, 9 is the set of odd numbers 1, 3, 5, oh no, careful, I said prime numbers less than 2. That's not 1, that's 2. So the set of prime numbers 2, 3, 5, 7 union the set of odd numbers is 1, 2, 3, 5, 0.79. There we go. Okay. Running out of room, so we need to make some more. Make some more room. Okay. Union of sets. Undefined. An impossible solution, or an impossible number. 5 divided by 0 is undefined. It's undefined because if we had the equation 5 divided by 0 equals x, that would be the equivalent of saying 5 equals x times 0. There is no number that you can multiply by 0 to get 5. Not even infinity. Infinity times 0 is still 0, not 5. So it is undefined. Quantity of interest. Interest. The target variable. So in the formula, A equals pi r squared, area is the quantity of interest. In the equation, velocity equals distance divided by time. Velocity is the quantity of interest. Units. Measurement. Measurement, what shall we say? Standard. They are things like inch for inch, IN for inch, FT for feet, S for seconds, and we have some combined units. M/S, meters per second. As a measurement of speed or velocity. Units. Constraint. Boundaries of a problem. So, for example, money hopefully is greater than 0, greater than or equal to 0. You can't have negative money unless you owe somebody some debt. If your solution is people, then no fractions or decimals. Those are constraints. Because you don't want to solve a problem with half a person. That would just be gross. We don't do that here. We're not that kind of class. Constraint. Viable solution. Okay. Not all solutions are practical. For example, if we did a problem where we were launching a rocket and wanted to find the time for it to reach the ground again, and we got a negative 2 seconds and a positive 21 seconds, the negative 2 seconds is not a viable solution because we don't go back in time. So we would take the 21 seconds as a viable solution. that is it.